continuing on in lesson 9.2, now we're going to talk about the graphs of exponential functions. So they have 4 graphs already here for us, and we're going to identify, from the equation itself, we're going to identify those parts we already know how to identify, and then we're going to make a relationship between those A's and those B values with what actually happens on the graph. Okay, so let's look at this first one. That's over here in the upper left-hand corner. Y equals 2 times 3 to the x power. What's our A value in that one?
2.
2. What's our B value? 3. Okay, does anybody remember what A tells us? What information does A give us?
It's the first
Start. It's the first term. It's where it starts, right? So this one starts at 2. Or in other words, if it starts there, remember, what is it that we would look for in our tables of ordered pairs? When we wanted the A value, what is it that we had to look for?
The 0.
The 0 for what? What had to equal 0 in our table if we wanted to be able to say the A value? The x value had to be 0, and then the y value would be your A. So in reality, this tells us right here that we have ordered pair 0, 2. That's really what that tells us. So could you guys engage here for me? On the graph, does that curve cross through that point, 0, 2?
Yes.
Yeah, it's right there on the y-axis, isn't it? So what do you think we could count on then? That A value is also known as the what? Not only the starting amount, but not the y-axis. The y-intercept. It's really like our y-intercept for our exponential function, isn't it? Because that's where it's crossing the y-axis at. Okay, then the B value, which we typically, in a linear equation, that's what we call the y-intercept. Well, not this time. In an exponential function, B plays a different role. What's the B playing? What's its role again?
Your common ratio.
It's the common ratio or the constant ratio. So let's just remind ourselves of that. That B is really saying, here's our constant ratio. In other words, the multiplier. And I'm going to guess that multiplier probably has something to do with, what do you think? Have you got any guesses what you think that multiplier does to the graph?
Move up.
How fast it moves up, maybe? Or how slow it moves up, or I don't know. Maybe after we do a few more of these, we can start comparing and see. Okay, so in this one, we actually had a positive A value, a positive B value, and which we should always have a positive B value, because remember it said B had to be greater than 0. It has to be positive. Remember in our notes earlier in this lesson, it said B had to be greater than 0. It had to be a positive number. What can't A be? What's the only restriction for A? A cannot be, what happens to 0? 0, because we multiplied by 0. Let's remind ourselves of that up here. Oh, it's there for us. Look at there. A cannot equal 0. B does not equal 1, it says. And B is greater than 0, or in other words, it's positive. So there's all of our things that we talked about already before. Okay, so notice what's happening with the graph. What quadrants is it in? What quadrants is the curve in? Only in 1 and 2, isn't it? Does it ever go down into 3 or 4?
No.
Okay, let me tell you something, even though it doesn't, you can't really tell for sure. It's really over here, approaching the x-axis, but it will never touch it. It will never actually touch it. It will never ever cross it and go down into quadrant 3. It will always stay up in just quadrants 1 and 2. Why don't you mark those quadrants up there? It will always stay in just quadrants 1 and 2. In this case. Okay, let's look at the next one. What's our A value in the next one?
-2.
-2. And our B value is 3. So remember, we now are going to have our thought process be not only is -2 the starting amount, but it's also the, what else is it? What's what's its new role it's taking on for the graph that we didn't talk about
Where
before?
it curves.
No, where it crosses the,
Y-axis.
where it crosses the y-axis. Look at there, it's crossing the y-axis at -2. What's different about this graph? Now that our b stayed the same, our a is a -2 instead of a +2.
It's
What's
going
different?
down.
It's going down. It's falling, and up here, it's never going to touch the x-axis. What quadrant? This is quadrant 3, and this is quadrant 4. And it's never going to get up into quadrant 1 or 2. So far it's kind of looking like the exponential function stays in in only 2 quadrants with the types that we're looking at here. Okay. Let's look at the next one down in the bottom left corner here. We have y equals 2 times 1/3 to the x power. What's our a value? 2. Or in other words, we're now going to say to ourselves, not only is that the starting amount, but it's what?
Where it crosses the y-axis.
Where it crosses the y-axis, where its y-intercept is. What's our b value this time?
1/3.
1/3. Oh. So this one's in quadrants 1 and 2, just like the one above it is. But what's different about this one?
It's going the other way.
It's going the other way. It's falling from left to right. When you look at it from left to right, it's falling. The other one is rising from left to right. What do you suppose is controlling that?
Your 1/3.
What's the only thing that's different? They're b values, right? So in the top one, b is greater than 0, or greater than 1, excuse me. B is greater than 1, and it's climbing from left to right. And here, b is between 0 and 1, and it's falling from left to right. But they both ended up in the same quadrant, because they both had a positive a value. Okay, and then let's look at our last one over here. What's our a value this time?
-2.
Now it's -2 again. It's crossing the y-axis at -2. Its b value is 1/3 again. And just like the one above it, it's in quadrants 3 and 4 only. Again, it's approaching the x-axis. It'll never touch it, never get there. So now this one is doing what from left to right? Falling or rising?
Falling.
From left to right.
Oh, rising.
It's rising from left to right, but not going up into those other quadrants, down in quadrants 3 and 4. So let's use the way the graphs are working here. Let's write down, oopsie, I need to put it on eraser, I guess. Let's write down off to the side of the graph what's actually going on here. So I'm going to go back up to here, and on this graph, what are we going to say? It's rising from
Left to right.
rising from left to right. Put these in your notes, please. Rising from left to right in quadrants, we'll call them quads, 1 and 2. So it's contained only in quadrants 1 and 2. That means it's above the x-axis. It's rising from left to right. Let's talk about the one next door to it. That's in quadrants 3 and 4. It is doing what from left to right? What's happening as you go across the graph from left to right? Is it rising or falling? So it's falling. So it's falling from left to right. In quads 3 and 4. Notice we don't ever use letters and numerals. We use Roman numerals for these. Okay, let's do the bottom one that I have in green over here. What's its behavior?
Falling left to right.
Falling. from left to right.
In quads 1 and 2.
In quads 1 and 2. And our last one. Its behavior, rising from left to right in quads 3 and 4. Okay, I want you now, the reason I have, you have graphing calculators, is I want you to with the graphing calculators, let's do some exploring here. Let's make sure that this behavior will always hold true according to what's going on with the A's and the B's, okay? So let's go back up to that first one where the A was positive and the B was positive. And we don't want to put in, you know, like since large numbers will never be able to see the graph. Let's change our A value to, I don't know, another column A value. Let's change it to 4. Okay, so let's go to your Y equals screen. Clear out anything that's in there. And we're going to put 4 times, and what do we need a positive B value. It can't be 1, but we don't necessarily want it to be too terribly big. Okay, let's just go with the 2. Okay, 2 to the X power.
Oh, how do I do that on here?
Yep, that little upside down B. Okay, and then do a zoom 6. And see if it has the same behavior this one does. A positive A value, a positive B value. Is it rising from left to right? Is it only up in quadrants 1 and 2? So a zoom 6 and it should have given you a good graph. I'm going to just come by and see your graphs and then you will swap up. Okay. So I'm thinking that we can then probably, since we checked out another one, we might be able to conjecture that if A is positive and B is positive, this is what we can expect. But not only does B have to be positive, what else has to be true about B? Not just positive, but greater than 1. Has to be greater than 1. So when B is greater than 1, so let's put that little stipulation up here now too. I want you to write that in this graph. This is above where we wrote these words. A is greater than 0. It has to be positive, in other words. When A is greater than 0, it's a positive number, and B is greater than 1, we can count on that behavior. If we don't get that kind of behavior on our graph, something went wrong. Okay, let's check out another one for this one over here where A was negative and B was positive. In other words, it was greater than 1 again, 2. So let's pick a new A value. Should we use -3? So in your calculator, remember the negative key is next to the enter key. So clear out the one you had in there and put in -3, y equals, we're in the y equals 3 again. Put in -3 times, and we need a B value greater than 1. 2, okay, 2 raised to the x power. Do we get the same behavior? In other words, is it falling from left to right? Is it in quadrants 3 and 4? Okay, so we're going to say we can count on this behavior when A is less than 0 and B is greater than 1. So this is the stipulations for that one. This is what we need for these behaviors. Okay, now let's go over and check out this one down in this corner. What do we have here? We have A is a positive number, and B is between 0 and 1. Let's come up with a different positive A value and a different fraction for B. 4. Okay, so let's go clear it out in y equals. Let's use let's do 4 times and 2/3. Okay, remember, we've got to put them in parentheses. So times, parenthesis, 2 divided by 3, parenthesis, raised to the x power. And you should be able to press graph, and what do you get?
The same thing.
You get the same behavior again, falling from left to right in quadrants 1 and 2.
I don't get it. So like the first one, both of them are positive.
Okay, but not only were they positive, but B was greater than 1.
Oh.
That's the difference. Here B is greater than 1, there the B is left between 0 and 1. Okay, so now we have to say, for this one, here's what we're going to. We're going to say that A is greater than 0, that's what we did. And B we're going to have to write a little bit differently here, you guys. It's going to be written as a compound inequality, okay? We're going to have to say 0. B has to be between 0 and 1. That's how we would write that. B has to be between 0 and 1. So A is greater than 0, it's a positive number. B is between 0 and 1. This is the behavior we can count on, falling from left to right in quadrants 1 and 2. Okay, and now our final one. This time our A value is less than 0, so let's pick a new one where A is less than 0. Let's just make sure.
A -3.
A -3, okay, so y equals, we're going to go in our y equals screen, we're going to say -3 times. We need a B value between 0 and 1 again. Let's use something other than thirds just in case I'm not clear. It's 1/2, okay? So what times 1/2, remember parenthesis, 1 divided by 2, parenthesis, raised to the x power. And what happened? Same behavior, okay? So if A is less than 0, in other words it's negative, and B is between 0 and 1, these are the restrictions. If that's the case, that's the behavior we can count on. Okay, well now that we have all the behaviors figured out, what our graphs should turn out like, let's see if we can answer some questions without graphing. Okay? When A is negative, the graph of y equals AB to the x power is contained entirely in quadrants 3 and 4. Is that a sometimes, always, or never?
Always.
When A is negative, the graph is contained entirely in quadrants 3 and 4.
Always.
Always? Well, let's look at our ones where A was negative. Okay, A was negative in blue one on mine. Is it in quadrants 3 and 4?
Yes.
Okay. In this one, it was in negative, or excuse me, A was negative again. Is it in quadrants 3 and 4?
Yes.
Okay, so we're going to say always. Okay, according to what we discovered up above, we can say that is always. Okay, well, how about number 2? The y-intercept of y equals AB to the x power is at A.
Always.
Always. We said A takes on a new role now too. It's not only the starting place, but we're also going to say it is the y-intercept. So that's an always. You can always count on A representing the y-intercept of the problem. Okay, number 3. When B is a fraction, in other words, B is between 0 and 1, the graph is contained entirely in quadrants 1 and 2.
Sometimes.
Go up there and see what happened. So here's our 2 where B is between 0 and 1. Oh, it's only sometimes, isn't it? Yeah, so it can't be, we can't say it always for that one. So why is this one in quadrants 3 and 4 then, instead of 1 and 2 like that one?
Because their A is negative.
Yeah, because the A is negative. Remember when the A was negative, it said it always puts it down in quadrants 3 and 4. Okay, number 4. The graph of y equals ab to the x power is a straight line. Never. That's an exponential function. Exponential functions will never give you a straight line. We know what kind of functions give us straight lines. Y equals mx plus b, or ax plus by equals c. When x is not in an exponent and it's to the first power, that's when we get a straight line. Okay, the graph of y equals ab to the x power is contained entirely in quadrants 1 and 2 when a is positive. Always. That's not always, isn't it? Up when a was positive, yep, that's where it ended up. Up in quadrants 1 and 2. Okay, the graph of an exponential function is in all 4 quadrants.
Never.
Never. It'll always be contained in. Now, notice that this is this format. Okay, we gotta think of it only when it's this format. When it's in this form, it's never. Okay, and then number 7. When b is greater than 1, the graph is contained entirely in quadrants 3 and 4.
Sometimes.
Sometimes. And when's that time it isn't again?
When it's negative. I meant when it's positive.
When a is positive, yeah. When the a controls some of it too, doesn't it? Okay, so that's just a sometimes. Now, when you're doing your graphing, when you're doing your homework, you're actually going to use this sheet to refer to say, okay, here's the kind of graph I should end up with. If I don't, something went wrong. Okay?
I don't get out of graph though.